Okay, hello everyone. I welcomes to all in our lecture series on Jacobian. We are discussing these topics. These topics are based on NEP syllabus, which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations also. In our last class, we discussed definition and application of Jacobian. Here, the definition in simply way we can say that if UV be the functions of two independent variables x and y, then the determinant, this one, del u by del x, del u by del y, del v by del x, del v by del y is called Jacobian of uv with respect to xy. In short, this determinant also represented as del uv by del xy or j whole bracket uv by xy. This is the Jacobian of two variables. Likewise, three variables also we can write in this format. Applications of Jacobian we discussed in our last class. In this class, we are going to discuss properties of Jacobian and their proofs. This is the first property. If j equal to del uv by del xy or Jacobian of uv with respect to xy and j star del xy by del uv or Jacobian of xy with respect to uv, then j star will be equal to 1. First property. This is the second property, also called as chain rule of Jacobian. This is the third property and this is the fourth property. One by one we are going to prove, okay, in this class. Now we are going to go for the first property and its corresponding proof. Here, if j equal to del uv by del xy, that means Jacobian of uv with respect to xy, where uv be the functions of two independent variables x and y, what I explained already written in the definition also. This is the Jacobian of uv with respect to xy, where uv be the functions of two independent variables x and y, and j star equal to del xy by del uv, or you can say Jacobian of xy with respect to uv, then j star will be equal to 1. This we have to prove here. Here proof starts by considering x and y be the functions of two independent variables p and q. Here u and v are the functions of x and y. Here u is the function of xy and v is the function of xy. But here, by considering x and y be the functions of other two independent variables p and q. Here x is the function of p and q, y is the function of p and q. It can be found that x is the function of uv and y also function of uv by solving the equations u equal to uxy and v equal to vxy. So how it is here, I am going to consider a simple example. Just watch. Here Jacobian, this one, Jacobian of uv with respect to xy, for u is the function of x, y, two independent variables. Let for this equation u is the function of xy, just we are going to consider x plus y is the equation. Now if v is the function of x and y, let that equation is your x minus y. Okay, so here we written as u equal to x plus y, v equal to x minus y. Now if we are going to solve these two equations, we are going to get the x and y value with the function of u and v, even if x and y are functions of other two independent variables p and q. कोई फर्क नहीं पड़ने वाला. अगर x and y functions of other two independent variables, then also by solving these two equations we can found x and y also functions of u and v. Here we have x plus y equal to v, x minus y, sorry, x plus y equal to u, and x minus v, y equal to v. Okay, now we found here, just add it, we can found 2x equal to u plus v, where x equal to u plus v by 2. And if I'm going to subtract these two equations, what we can get? We can get here, just to subtract, the x got cancelled, and here we found 2y equal to u minus v. So that implies y equal to u minus v by 2. So what we got from this here, x is the function of u and v, and here y is the function of u and v. Okay, so here, even if x and y are the functions of other two independent variables p and q, it can be found that x is the function of uv and y is the function of u and v also, by solving the two equations what we discussed now. Now consider the matrix form of Jacobian of uv with respect to xy, that is your del uv by del xy. So in matrix form, determinant form, we have to write del u by del x, del u by del y, del v by del x, del v by del y. J star, that means delta xy by delta uv, or you can say Jacobian of xy with respect to uv, in determinant form it will be written as del x by del y u, del x by del v, del y by del u, del y by del v. Just multiply these two determinants here. Simple determinant multiplication. This term multiplied with this term plus this term will be multiplied with this term. It's a first row multiplied with the first column. Here del u by del x into del x by del u by del x into del x by del u, plus del u by del y into del y by del u. Here it is written del u by del y into del y by del u. Then for this term, what we have to do? First row, second column, you just check del u by del x into del x by del v. Here this term, del u by del y into del y by del v, this term. Likewise for this term, second row, first column, and for this term, second row, second column. And we found these terms, okay, after multiplication of these two matrices. Next step here, same equation written again here. No need to write once again in your note, only once you have to write, because I should not have to move again and again the previous slide. Only for that I written over here. Here now we have to substitute, instead of this we have to substitute as 1, instead of this we have to substitute 0, instead of this 0, instead of this term we have to substitute 1. How? Here already we know, for this case u is the function of xy, hence the total derivative of u, if I'm going to consider, then du equal to del u by del x into dx plus del u by del y into dy. Now differentiate this one with respect to u again, del u by del u equal to del u by del x into del x by del u plus del u by del y into del y by del u, right? So here del u by del u equal to 1, and the same two terms written here. Considering for this del v by del u, that means here this one is going to differentiate with v, then right hand side will be del u by del x into del x by del v plus del u by del y into del y by del v. Okay, so here del u by del v will be equal to 0, is equal to same these two terms written as such. Okay, similarly the total derivative of v is, because v also function of x and y, so the total derivative of v will be written as dv equal to del v by del x into dx plus del v by del y into dy. That implies del v by del v equal to del v by del x here del x by del v plus del v by del y by del v. The left hand side will be equal to 1 because here del v by del v, so that implies del v by del v will be equal to 1, and these two terms written as such. If we are going to consider del v by del u for this case, then the right hand side will be equal to 0, and these two terms here, uh, this one will be differentiated with respect to u. So the left hand side will be equal to 0, and the right hand side will be del v by del x into del x by del u. Here del v by del y by del u. Okay. So here left hand side will be equal to 0, and the right hand side two terms written as such over here. Now we are going to compare this one, del u by del x by del u plus del u by del y by del u. Here we can found del u by del x by del u by del y into del y by del u. Value is how much? 1. Just write 1. So instead of this term, we can write 1. Consider this one, this term del u by del x by del v plus del u by del y into del y by del v. This one here we have, and this value is nothing but 0. Just substitute instead of this term 0 over here, and consider this one del v here, del v by del x into del x by del v plus del v by del y into del y by del v. Here the value of this one equal to 1. Just substitute over here. Instead of this, we can write 1, and this one here del v by del x into del x by del u plus del v by del y into del y by del u. Value is your 0. You just substitute instead of this term equal to 0 over here. Now the determinant value of this determinant will be equal to 1. Hence we prove this one j star equal to 1. Okay. Now we are going to go for our second property, this one. If u, v are functions of r, s and rs are functions of x and y, then del uv by del xy, or the Jacobian of uv with respect to xy, equal to del uv by del rs, or you can say Jacobian of uv with respect to rs into del rs by del xy. This is also called as the chain rule for Jacobian. Okay. Why it is called as the chain rule? Here you can see uv are the functions of rs. That means uv have the relation with r and s. rs have the relation with xy, but uv do not have direct relation with xy, but uv have the indirect relation with xy through rs. Here uv related with rs, rs related with here rs related with xy. That means uv indirectly related with xy, so that it is called as the chain rule. Now we are going to go for to prove this property. To prove this property, consider this part here, del uv by del rs into del rs by del xy. Now we have to write the determinant format of this and this. Here Jacobian of uv with respect to rs, corresponding determinant is del u by del r, del u by del s, del v by del r, del v by del s. Del rs by del xy, or Jacobian of rs with respect to xy, corresponding determinant is your del r by del x, del r by del y, del s by del x, del s by del y. Simple multiplication here. Here you can see this row multiplied with this column, del u by del r into del r by del x, this term, then del u by del s multiplied with del s by del x, this term. Okay. Now this row, this column, del u by del r into del r by del y here, plus del u by del s into del s by del y, this one. Then consider this row and this column, second row and first column for this term, Likewise, consider this one, this second row and second column for this term. Okay, let this is your equation number 1. Now here we know u v are functions of rs. That means u equal to u rs we can write, v equal to v rs we can write. Therefore the total derivative of u can be written as du equal to del u by del r into dr plus del u by del s into ds. Very simple. Now differentiate with respect to x. Del u by del x equal to del u by del r into del r by del x. Then del u by del s into del s by del x. Let this is your equation number 2. Again consider the differentiation of this equation with respect to y. Del u by del y will be equal to del u by del r into del r by del y plus del u by del s into del s by del y. Let this is your equation number 3. Similarly, if v is the function of rs, then total derivative of v is your dv equal to del v by del r into dr plus del v by del s into ds. Now consider del v by del x and del v by del y, this one and this one. Let this is your equation number 4 and 5. Here del v by del x means here del r by del x, del s by del x. Likewise we can get the equation number 5. Now put 3, 4, 5 equations in equation number 1 here in equation number 1. Okay, here you can see if I'm going to consider this one del u by del r into del r by del x plus del u by del s into del s by del x, this term here it is, here you can say same term del u by del r into del r by del x plus del u by del s into del s by del x. So instead of this term we can write what, del u by del x, right? Consider this term del u by del r into del r by del y plus del u by del s into del s by del y. Value is nothing but your equation number 3, that is your del u by del y. So here instead of this term we can write del u by del y. Likewise you just compare this equation, is same this one. So instead of this del v by del r by del x plus del v by del s into del s by del x, we can write del v by del x. Similarly, instead of this we can write del v by del y. You just check this one is nothing but this one. Okay, now we are going to substitute these terms. That means your equation number 2, 3, 4, 5 in equation number 1. So what we can get, we can get instead of this term is your du by del u by del x, instead of this term del u by del y. Here I written del u by del x, del u by del y, and this term, instead of this term we have to substitute del v by del x, instead of this term we have to substitute del v by del y, del v by del y. Mistakenly written x, this will be del v by del y. So if I'm going to write this one, this is nothing but your del u v by del xy. This determinant is nothing but your del u v by del xy, or you can say Jacobian of u v with respect to xy. Okay, so hence proved this property, chain rule of for Jacobian, that is your del u v by del rs into del rs by del xy equal to del u v by del xy. Here u v is not directly related with xy. uv is related or function of rs, and rs is the function of xy. So by this chain rule we can relate uv with respect to xy. So this is the proof of this property. Now we are going to move our next property, this one, property number 3. Here I am going to stop this class. In the next class we are going to prove property number 3 and property number 4. Okay, so thank you so much for watching this video. Thank you.